Good morning, friends. In our previous lecture, we discussed Bresenham algorithm and its flow chart, step by step, in which we conclude that this type of pixel, in this type of pixel, if our line will go in this direction, then uh, we have to take decision that our line will go from this pixel or this pixel. So it is decided by decision variable that we derived in our Bresenham algorithms theory. So based on that we will solve one numerical on this. So the question is, determine the raster scan location. Determine the raster scan location selected by Bresenham algorithm where generating a line from 10 to 10 3. So we have 2 points x1 y1 and xn yn. x1 is 1, y1 is 0, xn is 10 and yn is 3. So we already learn about DDA algorithm, and today we will learn how to solve numerical by Bresenham algorithm. Now we will find xn minus x1, it is delta x, and it is 10 minus 1 is equal to 9, and second one is delta y is yn minus y1 is a 3 minus 0 is equal to 3. So from this it is clear that delta x is greater than delta y. So in our all points we will consider delta x is equal to 1. So we will increment 1 point in our x direction, and for y direction we will use decision variable whether it is positive or negative. Now some quantity we will use in our numerical, so we will find it here. Xc is equal to xn minus x1 is equal to 10 minus 1 is 9, and yc is delta y, yn minus y1 is equal to 3. Now we will also use 2yc. 2yc is 2 into 3 is equal to 6, and another quantity is 2yc minus 2xc is 2 into 3, as yc is 3 and xc is 9, so 2 into 9 is equal to minus 12. Now for first point we just put x1 y1 is 1 and 0. Now it's time for decision variable. So for first point we will use always p1 is equal to 2yc minus xc, and 2yc is 6 we already derived, and minus xc is 9, so the answer is minus 3. So this answer is negative. So for next point we will use p1 is negative. So for next point p2, x2 is just give increment in x direction. So x2 is equal to x1 plus 1 is a 1 plus 1 is equal to 2. So we got the coordinates of x2. Now for y we'll just use decision variable. Here the p1 is less than 0 or negative, so we will use y2 is equal to y1 and y1 is 0, so answer of y2 will be 0. So our next point x2 y2 is 2 and 0. Now for next point we will use this equation, p2 is equal to p1 plus 2yc. So what was p1? p1 was minus 3. So we are just putting minus 3 instead of P1 and plus 2IC. 2IC is 6. So the answer is 3. So this is become positive. So next point, we will use x3 is equal to x2 plus 1 is equal to 2 plus 1 is equal to 3. And for y, as the value of P2 is greater than 0, so we will give increment in y direction also. So our point y3 will be y3 is equal to y2 plus 1 is equal to 0 plus 1 is 1. Now our decision variable become positive from negative. So the decision variable will be changed. Here we just use P1 plus 2yc, and for the positive decision variable we will use P3 is equal to P2 plus 2yc minus 2xc. So we know P2 is 3 and 2yc minus 2xc is minus 12. So our answer will be minus 9. Same, this is the negative answer. So we are just using y4 is equal to y3 is equal to 1, and for x coordinate we just give increment of 1 in x direction. As decision variable will become negative, so next decision variable we can find from this equation by adding 2yc in our previous decision variable. P3 plus 2yc is minus 9 plus 6 is equal to minus 3. Okay, so here we have to find the value of P is a decision variable. So whether it is greater than 0 or less than 0. If it is greater than 0, then we give increment in y direction. If it is negative, then we do not give increment in y direction. We are just using our previous coordinate for that new points. And same way we can use our equation is P is equal to, or Pk plus 1 is equal to Pk plus 2yc is for if the answer here, if the answer is greater than 0, if the answer is less than 0. If the answer is less than 0, then we will use Pk plus 2yc, and if it is less than 0, then we will use this equation. P3 is equal to P2 plus 2yc minus 2xc, and by solving other points we can get x5 y5 is 5-1, x6 y6 is 6-2, x7 y7 is 7-2, x8 y8 is 8-2, x9 y9 is 9-3, and x10 y10 is 10-3. Okay, so Bresenham algorithm is slightly difficult than DDA algorithm. So if in numerical always they say that you can use any algorithm. If it is specified that you have to use Bresenham algorithm, then you have to solve all numerical by Bresenham algorithm. If it is not specified in numerical, you should use DDA algorithm, as it is very easy than Bresenham algorithm. Okay, so it is 7 marks numerical. Okay, thank you.